Welcome to our, I think, third webinar in our series. So I know some of you might have heard this before, but just to those that are joining for the first time, this webinar series is part of our UK Freshwater Quality Research Programme, which started a year ago now, and it was funded by NERC and DEFRA. And just put up the objectives of this research programme for you to read. But it's really all about improving our understanding of the sources, the behaviour of pollutants within river systems and their impact on freshwater ecosystems. And really then to look at how we can reduce the pollutant load into our river systems and how they can become more resilient to climate change and land use change, and look at sort of adaptation and mitigation risks to improve our river ecosystems. So the next slide, Finn. So the programme funded 5 projects, and over the next 6 months, we're going to hear from each of them on a monthly basis through our webinar series. And it also has a programme champion team, which is myself and Jo Holden, and we're supported by Finn, Kath, Anne-Marie and Fahana here at Water at Leeds. And so again, you can quickly look at the projects, but today we're going to hear from ECOMIX, which is led by Alistair Boxall, who'll be presenting, and led out of York with collaborations with Sheffield and Durham. So next slide, please. You know, we're really trying to, through this webinar, get a community of practice, those that are involved in managing water systems, as well as academics working within this research area. So if you want to hear more about the programme, then there's these different ways you can engage with us. We've got an email address, freshwater@leeds.ac.uk, a website where you can find out a little bit more detail about each of the projects, and you can follow us on social media. And as Finn said, please do you know, try and join these. And this is our timetable for the next 6 months. You can see we've got all 5 of the funded projects. Plus next month at midday on the 15th of February, we'll be hearing from Rachel Cassidy, who's in AFBI in Northern Ireland, and she'll be telling us about their soil, nutrient and health scheme, which is looking at ways to improve water quality in Northern Ireland. So without further ado, I'll pass over to Alistair, who'll tell us more about how ECOMIX has been getting on over the last year. So over to you, Alistair.
Thanks, Pippa. So hopefully everyone can see the screen. Yep, I've got thumbs up, so I think we're good to go. So what I'm going to try and do in the next 40 minutes or so is give you an overview of what we've been doing in ECOMIX. Now, as Pippa says, the programme has been running for just over a year. As you can imagine, quite a lot of that year was taken up with getting things started, recruiting staff. So I don't have a lot of data to present yet. But what I'm going to try and do is just give you a bit of background to the project, and some of the work done prior to the project that we're building upon. I'll then talk a little bit about what we're trying to do in ECOMIX, and then I'll provide a little bit of an update of what we've been up to over the past year, and the different work packages. As Pippa says, it's a collaboration led by York, with Durham and Sheffield as partners, and then we have a number of associated partners involved in the project, who are shown at the bottom of the slide there. And that group is continually growing, so we are bringing new stakeholders into the project fairly continuously. Now, I think I'm the first of the projects to present, so I thought it would be probably worth just stepping back a little bit and talking about what we, and I think the programme is trying to do. And I think really it's all about trying to improve water quality in UK rivers. Our project is focusing on Yorkshire rivers, so obviously we're more interested in England's rivers, but we are developing approaches that will be able to be rolled out more broadly across the UK. So if you look at the statistics, 1 in 10 freshwater and wetland species are threatened with extinction. 2/3 of existing freshwater species are in decline. Few of our rivers have good ecological status when you look at the Water Framework Directive monitoring data. None of our rivers in 2019 met the criteria for good chemical status. And our rivers are under pressure from a whole range of different sort of sources. So we've got impacts from wastewater emissions, mining, and rural activities. And just over a year ago, so obviously this was discussed by the Select Committee down in London, and they defined rivers in England as being in a mess. They contain a chemical cocktail of sewage, agricultural waste, and plastics, which is continuously polluting many of our rivers. If we look at Yorkshire specifically, so I've got this information from the Yorkshire Wildlife Trust, only about 16% of Yorkshire's rivers are assessed as good ecological status in 2019, and our lowland rivers in particular are in a poor state. This is obviously also very topical in terms of the news, and I don't think you can get away from water pollution in the newspapers at the moment, and this has been going on for a year. And these are some of the headlines that have occurred. So, no river in England is free from chemical pollution. Our rivers are in a shocking state. They're failing pollution tests. I think the one that always makes me smile is the headline, "Sewage has left my river devoid of fish, says Lord." So I think we should be really worried about that. But then I think if you look to Yorkshire, we're facing the same issues in Yorkshire. So in York, there was a newspaper article last year where the anglers in York were warning about river pollution. And just over 3 or 4 months ago, there was a pollution incident up in Richmond and North Allerton, where there was a large fish kill. And last year in York, we had, unfortunately, a large fish kill in the Foss. Fortunately, we were out monitoring just around that fish kill, and we sort of analysed some of that water. And in the water, we found concentrations of paracetamol at 92 micrograms per litre. And just to put that into some perspective, if you look at some of the thousands of monitoring studies or monitoring data points that have been generated for Europe, that number is the second highest concentration ever reported in Europe. So, the state of our rivers is not great. And chemicals are contributing to that. If you look at urban systems, in our households, we typically use 4,000 chemicals in every household, and we will be emitting some of those chemicals down the wastewater system every day or down the outdoor drains. And obviously in our cities, we've also got other sources of emissions, so things like polycyclic aromatic hydrocarbons being emitted from cars, tyre particles that I'll talk about later coming from cars, wash off from buildings, so things like nanomaterials, and then the waste disposal from our urban areas. So when we look at urban areas, then we've got a real mix of substances going into our rivers, but then we've also got the wider environment in Yorkshire, where you've got perhaps heavy agriculture and arable agriculture, where you'll have heavy use of nutrients, but also pesticide applications. And then as we move up into the sort of dales, for example, you've got a lot of sheep and other livestock, and there you'll be having inputs from things like veterinary drugs into the aquatic system. So as a society then, in Yorkshire and in England more broadly, we're using a wide range of chemicals, and we're emitting a wide range of chemicals into the environment, which we think is probably not having a great effect on ecology and potentially also human health. And as a team, this is something that we've been working on heavily over the last 10 or 15 years. And I'll just give you a little bit of a flavour for some of the work that we've been doing in Yorkshire, and then begin to talk a little bit about how ECOMIX is building on that work, and then what we've been up to. So we, as a team, have worked on a wide range of different contaminant issues in rivers. So I'm not going to talk about it today, but we've done a lot of work on things like nanomaterials in the environment. I'll be presenting in a moment quite a lot of the information that we generated on levels of pharmaceutical pollution in the environment, both veterinary and human pharmaceuticals. We've done monitoring of metals across rivers in Yorkshire. I'll show in a moment some of the work that we've been doing on emissions from cars, and in particular tyre wear particles. And then increasingly we're doing more and more on things like pet medicines. So some of the things that we've not really sort of thought about so much previously, but I think we're beginning to recognise that in terms of impacts on ecology, they could be very important. And again, that's a group of chemicals that we'll be looking at in ECOMIX. So in terms of the pharmaceutical work that we've done, a lot of that work has been done on the river systems around York, in particular on the rivers Foss and the River Ouse. So this is just a couple of pictures of the River Foss. So the River Foss is the smaller river in York. It originates up in the Howardian Hills. So that photo on the left is a picture of pretty much the source of the River Foss, right up in the Howardian Hills. Then it flows down through the Howardian Hills, through quite a large area of arable farming into the city, where you then begin to get the city influence. And here you've got a picture of the River Foss. Just, you can see Clifford's Tower in the background there, and soon after that the river joins the main river in York, which is the River Ouse, which again originates as the Ure up in the Dales, and then it flows down through Yorkshire to York, and ultimately out into the Humber Estuary. And again, this is one of the main rivers and river systems that we'll be looking at in the ECOMIX project. But as I say, we've been working on both rivers quite extensively over many years now. We've been doing sort of studies where we look at a range of contaminants, and I'm going to show you some of the pharmaceutical data in a moment. So this is just a map of our typical study systems. And this is a sort of type of approach that we'll be using in ECOMIX. So we have different monitoring points that are along the river, focusing on different points of interest. So you can see the larger river there is the Ouse, marked with the points labelled O, and then the Foss is labelled F. And then you can see that we've got those red rectangles. They're the wastewater treatment plants that are in the system that we're monitoring. What we tend to do in that work is we will go out, we'll collect our water samples, and then we'll be bringing them back to the laboratories in York, where we have targeted mass spectrometry methods for a wide range of substances. And again, we're at the moment, and I'll show you some of the data later, at the moment we're sort of expanding those methods to sort of cover the sort of substances that we're looking at in ECOMIX, and we'll be building on those methodologies as the project progresses. So that sort of study data then begins to give us insights into what's happening in terms of inputs of chemicals to the rivers around York. These are monitoring data for a range of pharmaceuticals from some of the wastewater treatment systems. So these are two of the wastewater treatment plants that we monitored. One is an activated sludge plant, and the other is a trickling filter plant. On the x-axis, you can see the different active ingredients that we detected in those studies. And then on the y-axis, you can see the level of removal of the different compounds that we're detecting between the influent, so what's going into the wastewater treatment works, and then the effluent, what comes out of the wastewater treatment works. And from this, you can see that many of these substances do survive the wastewater treatment plant treatment. So to the left of the graph, you can see that there are substances where you haven't got very much removal of the substances. In some of the substances, you're actually seeing formation of the substances, or what appears to be formation of the substances in the wastewater treatment process. We think that's probably due to the fact that some of these substances are metabolized by the human, and once those metabolites go into the wastewater treatment plant, they're reconverted back to the parent compound by the bacteria, and hence you see a higher concentration in the effluent from the wastewater treatment works. And then on the right, you can see that we see some substances, such as paracetamol, which is by far the biggest used active ingredient in the UK, is very well removed by wastewater treatment works. So the paracetamol signal that I talked about in the FOSS a few slides ago, that is really an indication that there was untreated wastewater entering the river during that river fish kill. In terms of the rivers themselves, we detect a wide range of different sort of compounds. So again, you can see on this graph, we've got the different active ingredients on the x-axis. The slightly darker bars are the median concentrations that we see across a year in the River Ouse, and then the green bars are the maximum concentrations that we measure. When we look at these pharmaceuticals, the two compounds that we always see as the highest concentrations are metformin and gabapentin. So sort of metformin is a type 2 diabetes treatment. So the fact that we're seeing so much metformin in the system is really just a reflection of the fact that the incidence of diabetes is quite widespread in the UK. And then we see very similar data for the River Foss. So again, we see very similar patterns in terms of pharmaceutical pollution, but we see higher concentrations. So even though the River Foss is a much sort of lower populated system, so the wastewater treatment works on the River Foss only takes wastewater from about 19,000 people, we do see sort of higher concentrations than we see in the Ouse, and this is really just a reflection of the differences in the flow of the two rivers. So obviously the Foss is a much lower flow river than the River Ouse. Those data then begin to allow us to begin to understand how patterns of contamination vary across the year. So the schematic at the bottom there just illustrates the different sampling points along the River Foss. You can see on the left, we have a point upstream of the main wastewater treatment works on the Foss, and then we've got points sort of moving downstream from the wastewater treatment plant. And then at the top there, you can see we have monthly total concentrations for each of all of the different pharmaceuticals that we monitor at each of those points. So using this type of data, then we can begin to understand seasonal variations in concentrations of these compounds, and we can also begin to understand spatial differences in the concentrations of these compounds. You can see on the three bar charts on the right, you can see there's a big peak around March. So that is those three big red bars. That's again down to paracetamol. So the main contribution to that to those peaks is paracetamol, and again that's an indication that at that sampling time the combined sewer overflows are probably operating in the system. As I said, these data also allow us to begin to understand how the substances dissipate as you move away from the point of discharge. So here we have the different monitoring points on the River Foss. The bar on the left in each cluster is upstream of the wastewater treatment works, and then the blue bar is just downstream of the wastewater treatment works, and then you can, for different compounds, you can then begin to see how concentrations of the pharmaceuticals dissipate as you move away from the emission point down towards the confluence with the River Ouse. So hopefully that gives you a little bit of a flavour for some of the work that we've been doing on pharmaceutical pollutants. Durham have also been doing similar types of studies. They've been focusing on the air. So this was part of a EU Marie Curie project. In this study, they've not just looked at human pharmaceuticals, they've also looked at some of the veterinary medicines. So you can see that the different compounds are there that they were looked at in their study. So carbamazepine, lidocaine, erythromycin, sucralose, and atenolol are all human drugs, or sucralose is also a sugar additive, and cypermethrin is a veterinary medicine. It's also a pesticide, and it's used quite heavily in sheep farming, I think. So we or Durham did monitoring of the river air, and they sort of developed a picture of concentrations of those different determinants across the river air. So you can see a map of the river air there at the top of the catchment. That's obviously up in the Dales, up in Malham area. You can see that most of the compounds, they're not really detecting very much. Again, that's probably a reflection of the low population density of the humans in this area. But for cypermethrin, you are seeing concentrations of cypermethrin right at the top of the catchment. And cypermethrin is actually one of the ECOMIX study compounds. We've also been doing work in the national parks more generally. And as part of that, we've done monitoring of pharmaceuticals in the Dales and a number of rivers across the Dales, and also up in the moors. So looking at the Esk and the Leven rivers up in the moors, which aren't actually in the ECOMIX project, but they are part of the region, and they're in Yorkshire. And we do find pharmaceuticals even in some of the very remote locations. And we think this is probably due to inputs from things like septic tanks and some of the really small water treatment works that are dotted around these parks. So hopefully that gives you a feel for some of the stuff that we've been doing on the sort of more traditional organic substances. We've also been looking at, I guess, some of the other emerging contaminants. So over the past couple of years, we've had work at York looking at tyre wear particles. So when we drive our cars and lorries, every kilometre that we're driving, our tyres will be producing somewhere between 37 and 73 particles per kilometre. That equates to about 42,000 to 84,000 tonnes of particles released to the UK environment each year. That material, a lot of that material, will be washed off the highways out into our rivers. And these particles are not only made up of the tyre material and the additives in that tyre material, but they also pick up some quite nasty substances such as polycyclic aromatic hydrocarbons and also metal contaminants coming from the cars. We've had work monitoring concentrations of these materials in the ooze and the foss. So some of the data here are shown here. So we have data in the left there for the ooze and on the right for the foss, looking at the sort of average concentrations of tyre wear particles over a year. You can see a few of the images there at the bottom. These are extracts of the sediments taken from each of the monitoring points that we're looking at in that study. And you can see the sort of different tyre particles there that have been extracted from this study. And then at the bottom there, you can see the most polluted site. So that's around Bluebridge, which is where the foss and the ooze converge. Now, quite interestingly, and perhaps not surprisingly, that sediment was also packed with other microplastics. So these are some of the images from the sediment extracts. You can see you've got a mixture there of fragments, so secondary microplastics being formed from perhaps degradation of things like paints and coatings and plastic bags. And you can also see we're detecting a range of fibrous microplastics in the sediment. And just like the pharmaceuticals, we're able to begin to get an idea of how the concentrations in the sediments of microplastics and the tyre particles vary both spatially and temporally. So this is some of the spatial data there, but also using some of the analytical methodologies, we're able to begin to get a picture of what these particles are comprising. So it's a mixture of things like polypropylene, polystyrene, nylon, PVC, PET, and polymethyl methacrylate. So hopefully that's given you a flavour for some of the things that we're doing and some of the things that we're building on in the project. Now, obviously, the Environment Agency are also monitoring the system quite heavily. So as part of the Environment Agency, there's quite a lot of broad-scale monitoring to support sort of monitoring of things like the Water Framework Directive priority substances. But the Environment Agency do also have continuous monitoring points where they are monitoring a much wider range of substances and using some of their sort of non-targeted methods to look at water quality. And looking at that data, you know, some of these points in Yorkshire contain the sorts of things that we've detected. So they contain pharmaceuticals, veterinary medicines, but also things like combustion products, personal care products, and general industrial chemicals. So hopefully what that's beginning to show is that our rivers in Yorkshire are contaminated with a real complex mixture of things. We do try to make sense of the data and try to model the data, and we're building on this as part of ECOMIX. So this is just some analyses where we brought together information on flow in the systems that we monitor, and also prescription data. And then we've looked at the relationship between flow and prescription data with what we detect in the river. And you can see that there's a really good relationship between what we detect in terms of pharmaceutical pollution in our rivers with what we use in terms of prescription of pharmaceuticals, but also in terms of what the rivers are doing in terms of dilution of the effluent that goes into the rivers. And what that means is that we can begin then to model exposure. Over the past few years, we've been working on developing a high resolution spatial model that's been set up for the region. So it's been set up and it's been validated for the region, but we're now working on another project where we're expanding that model across the whole of Europe. So this is called EPI. And what EPI allows us to do then is begin to input data on prescription numbers and amounts in the area, information on the metabolism, removal and wastewater treatment, and the physicochemical properties of the chemical. And what that allows us to do then is begin to estimate concentrations of these pharmaceuticals at very high spatial and resolutions. And what we're doing in ECOMIX is we're building on this concept to begin to expand that out also temporally. So we're beginning to move to a model that allows us to estimate concentrations, not just at high spatial resolutions, but also high temporal resolutions. What that allows us to do then is to then begin to look at risks across the system. So with the pharmaceuticals, what we've been doing is working with these modeling approaches alongside ecotoxicity data to begin to understand where hotspots of risks are. So this is just a risk map for one substance. So this is an antidepressant. And you can see here the rivers across the region have been shaded in terms of the level of effect that we're estimating based on the model predictions of concentration and the ecotoxicity data for that antidepressant. But expanding that more broadly, we've done that for now a whole range of different active ingredients using a whole range of different ecotoxicity data. And this is just an analysis where we've run it for the local catchments. And you can see that for some of these pharmaceuticals, the concentrations that we're predicting across quite a broad area of the sort of catchments that we've monitored actually are high enough where in the laboratory, you know, effects on different organisms in the laboratory, different organisms have been reported. So this includes things like effects on invertebrates, fish, and aquatic plants. So I think what this is all telling us is that we've got inputs into Yorkshire's rivers from a wide range of sources. We've got lots of different contaminants going into the system. That pollution is widespread, but you do see spatial differences in the patterns of pollution. I think what we're showing is that using information on land use, hydrology, chemical behavior, and what we can begin to do is estimate concentrations of pollutants quite well, actually, and come up with very good estimates of exposure. And using those models, then we're able to begin to look at what the level of risk is, and what that's suggesting is that for selected pollutants, the concentrations that we see in the region are at levels that we should be concerned about in terms of ecological health. But there is, I think, quite a lot of uncertainty in all of that work. So what I presented today, we focused on quite a lot of substances, but those substances represent only a small fraction of the chemicals that we use in Yorkshire. When we do the assessments, we tend to take a one-by-one approach. So we tend to look at risk of individual substances. In terms of the effects side, a lot of the effects data that we're using is based on standard toxicological laboratory tests with standard organisms. Those organisms might not relate very well to organisms that actually occur in Yorkshire's rivers. We ignore the fact that the characteristics of the catchment vary over space and time. So things like pH and dissolved organic carbon are likely to be affecting the impact of these substances, but we don't consider that in our modelling efforts. We don't think about how the chemicals will interact with co-stressors. So how will nutrients impact the toxicity of some of these synthetic chemicals? How will temperature affect the toxicity of some of these chemicals? And then I think if we look into the future under things like climate change and other sort of global megatrends, it's likely that the system is going to change quite dramatically. So what we're seeing today could be very different from what's going to happen in the future. And I think if we're going to protect our rivers, we need to begin to address that. And this is really what we're trying to do in ECOMIX. So we're trying to develop a new transformative catchment approach that begins to consider the chemicals that really matter in the catchment, begins to think about the mixture interactions, but also how those chemical mixtures interact with co-stressors, but also to begin to think about the mixtures of species that actually occur in Yorkshire's rivers. So what is the impact of chemical mixtures and co-stressors on the mixtures of species in Yorkshire's rivers? We want to look to the future. So we want to begin to think about what the impacts of global megatrends are going to be on how we use chemicals, how chemicals are going to move into the environment, how they're going to behave in the environment, and how they're going to affect the environment. And we think if we can do that, what it's going to allow us to do is begin to target interventions where they're going to have the maximum impact, so that we can begin to target those interventions and introduce those interventions. So as we move forwards, we improve the sort of quality and biodiversity in Yorkshire's rivers. Now, to do that, we have developed an overall conceptual framework, which is illustrated here. And the idea is that we will bring together information on land use, weather characteristics from climate projections, information on the catchment properties. They will then be used together to define the characteristics of the river, so the flow of the river, but also the sort of geochemistry of the river, the chemical use and chemical use patterns in the catchment, and then using information on the exposure profiles, ecotoxicity data, and knowledge of how chemicals interact with modifiers of toxicity, and also ecological sort of models will be able then to begin to understand the impacts of the chemical exposure on biodiversity and ecosystem function. So that's the general idea. The project is a 4-year project. So as I said at the start, we are a year in. It's been delivered through 6 work packages. So these are shown here. So work package 1 is all about identifying the case study chemicals. Then we have a series of work packages working in tandem, where we begin to estimate current and future use of chemicals in the region. We begin to understand current and future exposure profiles for chemicals and co-stressors in the region, and we begin to understand the effects of those chemicals on species in the region. Those data then will feed into ecological effects modelling, sort of work where we'll begin to look at the effects of the mixtures on ecology at very fine spatial resolution. And what that will allow us to do then is begin to identify the hotspots of risk and also what's driving that risk. And our hope is that that will then allow us to move into work package 6, where we will identify how we're going to fix the problem. So what adaptation and mitigation strategies are needed to fix the problem. Now, throughout the process, we're really keen to be working with the partner organisations. So each step, partner organisations are going to be involved in the co-design and co-delivery of the project. So this is already happening. They've been heavily involved in the prioritisation process, and over the past 6 months or so, they've been very heavily involved in the design of the monitoring programme. So I'm just going to give you a quick overview of what we've been up to. So in work package 1 then, we have worked to identify the chemicals that we'll look at in the project. The way we've approached this is we've pulled together information from previous prioritisation exercises of different classes of contaminant into in the UK environment, and we fed all of the chemicals from these different prioritisation approaches through a sort of funneling approach. So it's a mixture of chemicals. It includes pesticides, pet medicines, pharmaceuticals, livestock medicines, biocides, personal care products, metals, and some industrial chemicals. And what we've done working with the sort of stakeholder organisations is begin to, from a list of about 300 substances, narrow that down to a list of just over 40 substances that we are taking them forward in the rest of the project. And those substances have been selected to originate from different sources, have different ecotoxicological profiles. So some we'll expect to be highly toxic to primary producers, whereas others will be highly toxic to invertebrate communities. They have different modes of action and also different chemical properties. So this is the ECOMIX mix. So you can see there the different classes. So we have some pet medicines, so things like fipronil, imidacloprid. We have arable pesticides. So here we got some herbicides and some fungicides, livestock medicines, so some of the antiparasitic substances, but also some of the antibiotics. We've got a mixture of pharmaceuticals. We've got some antifungals, some antidepressants, some antibiotics, some anti-inflammatory drugs, also metformin, which I mentioned earlier. We've got a range of personal care products. So this includes things like some of the preservatives used in personal care products, but also some of the UV filters. And then we have things coming from cars, so things like the polycyclic aromatic hydrocarbons, 6-PPD, which is the tire additive that has been associated with the effects on the coho salmon in the west coast of the US, and also some metals. For each of those groups of substances, we've been spending quite a lot of time mapping the distribution of the sources of those substances across the region. So we split the region up into around 50 subcatchments, and we pulled together information on things like population density, traffic volumes, industrial discharge consents, CSO density, arable farming data, livestock densities, and also presence of legacy mines, to begin to map out where the major sources of each of these substance classes will be. And you can see here we've got a few maps just sort of showing the results of that exercise. That then has allowed us to begin to develop the modelling and monitoring work. So in terms of the modelling, we have been working to develop the hydrological models of the system. So here we're using HYPE, which is a hydrological and biogeochemical model. So this is work that's been done at Durham. And what we've been working on is working towards developing HYPE so that we can begin to generate information on water flow, but also biogeochemistry in the river systems across the region. and that then will give us the dilution data for our chemical exposure models, but it will also give us some of the co-stressor data that we need to begin to look at the interactions of the chemicals with co-stressors. We have focused in terms of the chemical exposure modeling on pesticides and pharmaceuticals to date. So in terms of the pesticides, we now have quite fine resolution data on pesticide usage and the associated parameters for the different case study compounds. We brought information on land use from the CEH land cover maps for the region, and also information on, on the soil characteristics across the region. And we're working at the moment to develop that into a system where we can begin to estimate concentrations of pesticides at very fine resolutions. A similar thing has been done for the pharmaceuticals. So we've been working on pulling together NHS prescription data at quite a fine resolution. So we've been using GP practice level data. We've been associating that data with wastewater treatment plants across Yorkshire, and we've also been bringing in information on the fate and behaviour of the pharmaceuticals. And again, that will be feeding into models to estimate the concentration of pharmaceuticals. I think here it will likely be monthly resolution across the region, very fine spatial resolution. Now, monitoring is going to be used to evaluate and test the model predictions. So we've been working with the maps of source densities to begin to design a monitoring study. We now at a stage where we've located 21 locations across the region where we will be instrumenting them with automatic water samplers, which will be taking water continuously across a 12-month period. And those samples will be analysed at a weekly resolution. So we'll have weekly composite data that will be analysed for each of our study compounds. And that's really going to provide a really sort of cool data set on how exposure to these compounds varies spatially across the region. I think what's fun with some of that work is we've identified a number of quite iconic sites as locations for sampling. So it includes a number of National Trust properties. So you've got East Riddleston Hall there in the left, Nunnington Hall in the bottom right. You've got the Hepworth Gallery over in Wakefield will be hosting a sampler. The museums in Leeds, the Industrial Museum in Leeds will be hosting a sampler. We've got Heritage Trust in Castleford hosting a sampler. The Merchant Adventurers in York will be hosting a sampler. And in the bottom left there, we've got the Howsham Mill Trust, which is on the Derwent, will be hosting a sampler. So as you go around Yorkshire, if you're coming to Yorkshire on your holidays this year and you visit some of your sites, these sites, you might want to just keep an eye out for the ECOMIX samplers. We've been working hard on the analytical method development. So as I say earlier on, we have very good methods for things like pharmaceuticals. We've been extending those to include the new study compounds. We're now at a stage where we have an LCMS method up and running for 46 of the compounds, and that's just about validated and ready to go. And then we have 17 compounds that a GCMS method has been developed for. Some of these compounds you can see here, we actually have more compounds that are on the ECOMIX list. I think when Pippa introduced the different projects, she mentioned the LTLS project, which is led by CEH. What we've done is we tried to work in some of the compounds on their priority list into our method so that we won't just be generating data for the ECOMIX project, we'll also be generating data for the CEH project as well. So there we've got an overlap with the two projects. In terms of the ecotoxicity, we've been working on setting up all of the cultures. So we now have cultures of 9 diatoms up and running, and we've done our first sort of ecotoxicity studies with the diatoms. And similarly with the invertebrates, we've been sort of getting all of the invertebrate test species up and running. You can see it's a mixture of things like mollusks, amphipods, worms, and those have been used to test a range of the case study compounds, and we're beginning to get a picture of the sensitivity of some of these species to the different case study compounds. So this is just data for permethrin. So you can see here we've got the different concentrations that have been used for different concentration response relationships that were developed for permethrin, and some initial work has been done looking at working that data alongside existing data on permethrin to begin to understand the relative sensitivity of the species that we tested compared to other species that have been tested, and also to develop species sensitivity distributions for the molecule. So I can see Pip has just turned her video on, so I'm obviously rabbiting on far too much, but I am beginning to come to an end. So looking forwards then, while we don't really have much data yet, I think everything is progressing well, and looking forwards, we're well placed to begin to deliver what we proposed in the proposal. So we will be delivering current and future chemical use and exposure scenarios. We'll be delivering this high resolution modelling system, which will be validated against the experimental data. We'll have the new models for effects, looking at how toxicity modifiers affect bioavailability and ecotoxicity. We'll have read-across methods for effects, and also, we've not started this yet, we'll also be beginning to look at how we begin to handle this issue of mixtures of chemicals, mixtures of co-stressors, and how they impact mixtures of species. And taken together, I think this is going to give us a very powerful assessment framework that allows us to much better understand the impacts of chemical pollution on systems in Yorkshire, but also more widely. So just to finish then, hopefully I've convinced you that there are issues around chemical contamination of Yorkshire's rivers. There's a lot of different chemicals going into our rivers from lots of different sources, many of which we've ignored up until now. When we look at some of the data that we've generated previously, some of these do appear to be a concern in terms of ecological risks, but there are many uncertainties, and I talked about those a little while ago. And what we're hoping to do in ECOMIX is really address these uncertainties, so we begin to get a much better understanding of what the actual impact of chemical mixtures is on our systems, and also where the risks are and what we can do about it. And hopefully that will lead to improvement in water quality across the region, but also more generally. But as you can imagine, we have a very busy year ahead. So we've got all our ducks in a row, I think. And over the next year, I think we're going to have quite a lot of fun generating all of the exposure data, the modelling data, and the ecotoxicity data. So hopefully in a year's time, when I assume I'll be doing another talk, I'll have a lot more to present on what we're finding in the project. So I will stop there, and I'll be happy to answer any questions.